Hello everyone, Mr. Skelton here, back at it for the last lesson in Unit 6, and today we're going to be talking about some inequalities in triangles. Just a reminder, inequalities represent, your greater than or less than. Inequality means not equal to, okay? And so what we're going to be doing is comparing angles and sides and looking at how longer sides affect the angles and how bigger angles or smaller angles affect the sides. So jump right into it here. First thing is a theorem which basically states that if two sides of a triangle are not equal, let me say congruent. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. This is very important, and I'm going to try to show you an example of how this works, but the larger angle is always opposite the longer side, okay? And that should make sense to you. If I had, I'm going to try to give you an example here. If I had 10 for a side, okay? I'm going to make a little triangle here, hopefully. If that was 10, and then I have a side that's double that, which is 20, don't you think that this angle here would be smaller than this angle here? Because to make this angle of 20, or to make this side of 20, that's going to open up the angle. The angle's got to be larger to reach out to the corners to hit the 20, to make 20. Where 10 is a little bit shrunk. I used to do this example with my hands, and I know it's hard to see, but I used to make like an angle here. You can kind of see a V with my hands. And if I open up my hands wider, the distance between my middle fingers here, that distance gets larger. So as I close my hands together and shrink the angle down by my palms, the distance between my middle fingers gets smaller. If I make the angle bigger by my palms, the distance between my middle fingers gets larger. So that's kind of an example of this theorem, okay? So how do you apply that to problems? Well, you have something like this. List the angles in order from largest to smallest. So if you're listing the angles, and this is where kids screw this up, it says list the angles. So what you need to do is look at your sides, which one's the biggest. So this is your biggest, so that's your biggest, 5.8. So that means K, because K is opposite of 5.8. I just draw a line. Angle K is the largest angle. What's the next largest side? 4.3. What's opposite of 4.3? Angle L. And you have 2.7, which is the smallest, so opposite of 2.7 is angle N. Okay? Now it says, I put a little note here, it says, notice, you can only estimate these angles. All right, we don't know the actual degree, okay, or measure. We don't know the actual measure of K. I'm not measuring it. I don't know if that's 72 or whatever. We're just going based off of the side lengths, all right? Now, the other type of question you can get that applies to that theorem we just talked about is you'll just get a written statement, like this example. And it's very difficult with no picture. So what you need to do is draw triangle PHT. So it says in PHT, blah, 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 you can read. So just draw PHT and just remember to go in order. It doesn't matter where you start the P. I just went PHT. And then label pH. pH is 16, so put a 16 there. TP is 20, and TH is 13. Okay, so now you have a picture just like the one we just did right above. List the angles. I always underline what they want me to find. Angles from largest to smallest. So 20 is my largest side. So what's opposite of 20? Just draw a line, H. Second largest side is 16. Opposite of 16 is T. 13 is my smallest side. Draw a line opposite the angle, angle P. Okay? Now, Theorem 2 is just the opposite of Theorem 1. It basically says this: if two angles of a triangle are not congruent, then the larger side lies opposite the larger angle. So it's just reverse. It's the same thing we just did, but reverse. So now I'm giving you angles, and we want you to list the sides. I'm going to have a lot of students on the quiz or test get confused. Please, please, please make sure you understand what I'm asking you to list. I'm asking you to list the sides in order from smallest to largest this time. And always look at the directions. Kids think these are really easy, which they are, but if you don't read the directions carefully, you know, like look right up above here, I put list from largest to smallest. Now I'm asking from smallest to largest, so just make sure you know. So for this problem, you have 45 degrees, which is in this angle. 75 is right here. You need to find the other one, so add 45 and 75, subtract from 180. That gives you a measure of 60 degrees. So sides, smallest to largest. So I'm looking for my smallest angle, 45. What side is opposite? Just draw a line, MN. 60 is my next smallest. So draw a line opposite till it hits the side, ON. And you could call this NM and NO, it doesn't matter. 75 is my largest, so that would be MO. And you're done. Okay, over on the back. Same question as kind of on the front. There's no picture. You want to draw a picture. D, V, Q. So I'm going to draw D, V, Q. And again, your vertices don't have to be the same as mine. And let's fill them in. Angle D is 51 degrees. It tells us right here. V is 4x plus 3. And Q is 5x minus 9. Or, excuse me, 5x minus 18. Now, a little trickier here. It does say to list the sides in order from longest to shortest. I need to figure out what these angle measures are, though. Now, we know that a triangle makes 180, so I'm actually going to add all of these up. 4x plus 3 plus 5x minus 18 plus 51 equals 180. All right, so 4 and 5x make 9x. I'm going to get my calculator out here. I got 3 plus 51 minus the 18 gives me 36. That's equal to 180, so I'm going to subtract 36 from 180, so 180 minus 36 is 144, so 9x equals 144. You divide that by 9, and you get 16. Now, why is that important? Well, if x is 16, I can find what angle V is by taking 16 and timesing it by 4, and then adding 3 to it, and I get 67 degrees. So that's 67 degrees here, and then I can do the same thing to find Q. 5 times 16, and then minus 18, and that gives you 62 degrees. Okay? If you need to redraw the triangle so that you can kind of see it a little bit more clearly, you can, but just understand that the angle measures are 51 for D, 67 for V, and 62 for Q. You should be in good shape. Now, recheck the directions. Longest side to shortest. So what's my longest side? My longest side is going to be opposite my largest angle. My largest angle is 67. Opposite of it is DQ. Dairy Queen. Yeah, yeah. 62 is my next largest. Draw a line opposite, DV. And then 51 is my smallest, which is opposite of that would be VQ. And again, you could put QD, VD, and QV, same thing. All right. Next example, which side, always look at what they're asking you, is the shortest in the whole diagram. Well, we've got to do some angle finding here. I'm going to cover that up. This is 90. That's 40, which makes 130. So that means this has to be 50 degrees to make 180, right? Okay. And then, 90 and 40 make 130. This needs to be 70 to make, nope, I think I was right the first time. 90 and 40 is 130. So 130 from 180 would be 50. I don't know why I put 70. So 50 there. Okay. This is an isosceles triangle. If you look at it like this and cover this part up, you have an isosceles triangle. So you know these base angles have to be the same. So 30 from 180 is 150. 150 cut in half is 75 degrees and 75 degrees. Now, if you look at all your angle measures, you have 30, 75, 75, 40, 50, and 90. Which side is the shortest? So you got to find the smallest angle, which is 30. What side is opposite of that? QR. Okay. Last thing from the notes is what's called the triangle inequality theorem. And it basically says this: the sum, which means to add, if you add the lengths of any two sides of a triangle, it has to be greater than the lengths of the third side. Now, this should make sense to you here. Let me show you an example of why this doesn't, of a situation where it doesn't work. If I told you the sides of a triangle were 1, 1, and 3, would that be able to make a triangle? If you were to put those sides together, would that make sense? Just let's take a look at that. If that distance is 3 right there, okay, and I'll put a little dot in the middle, so, well, I won't put a dot in the middle. Let's just say this is a length of 3, whatever, 3 inches, 3 feet. If the other two sides are 1, they're too short to come together. It doesn't make sense. If you want a different example that's very similar, 1, 1, and 10. If I had a side of 10, and then the other two sides were 1, that can't make a triangle because those ones will never come together. They're not long enough, okay? So that's kind of an indirect proof showing you that why it doesn't work and why this has to work. You have to have two sides greater than the third. So how do we apply this? Kind of like what I was just doing in those pictures, okay? Can a triangle have the given side lengths of 4, 6, and 9? Here's how you do these, okay? This is how you use the theorem. You just find the two smallest sides, add them, and see if it's bigger than the other side listed. For example, 1, 1, and 3. My two smallest sides are 1 and 1. Add those together gives you 2. Is 2 bigger than 3? No. So this can't work, and I just showed you why it can't work. 1, 1, and 10. My two smallest sides are 1 and 1. Add them together. 1 plus 1 is 2. Is 2 bigger than 10? No, it doesn't work. Come down here. 4 and 6. 4 plus 6 is 10. Is 10 bigger than 9? Yes. So, yes, that works. Okay? And you can go through this. You can go 4 plus 6 bigger than 9. 4 plus 9 bigger than 6. 9 plus 6 bigger than 4. You can go through all three scenarios, but these all work. 10 is bigger than 9, 13 bigger than 6, 15 bigger than 4. They all check off. I kind of gave you the shortcut to start with. Look at this one. What are your two smallest sides? 3 and 7. Is 3 plus 7 bigger than 12? 3 plus 7 is 10. Is 10 bigger than 12? Of course not. So you would say, no, that doesn't work. Just like this situation right here. Now, this one's the tricky one. 5, 5, and 10. Your two smallest sides are 5 and 5. 5 plus 5 is 10. Is 10 bigger than 10? It's not. Now, if I had an or equal to sign, that's different, but we don't. They have to be bigger than. They have to be greater than. It doesn't say greater than or equal to. It just says greater than. So this would not work, so this is a no. Okay. Last thing that you're going to have to do is very similar to what you were doing up here. It says the lengths of two sides of a triangle are given. Find all the possible lengths of the third side. Okay? Now, you can make this really, really easy. All you have to do is add the two numbers together and subtract the two numbers together, and you make an inequality. It works like this. What's 9 plus 7? 9 plus 7 is 16. What's 9 minus 7? It's 2. You always take the larger side and subtract it. So I'm going to say x, okay? And you're going to make a compound inequality. So x, or the third side, because it says find all the possible lengths of the third side, that third side could be between 16 and 2. It has to be bigger, or excuse me, it has to be smaller than 15, but it has to be larger than 2. And that should make sense. Like pick a number like 3. So let's say I use 3, 3, 7, and 9. And just do what we did up here. Is 3 plus 7 bigger than 9? It is. If I picked 15, okay, 15, 7, and 9. Is 7 plus 9 bigger than 15. 7 and 9 make 16. 16 is bigger than 15. Okay? So over here, I add them together. 23 and 14 is 37. Always take the larger side, 23, subtract it from 14, which is 9. So I put my larger number here, the subtraction one here. I always put my side in the middle. It has to be smaller than 37, and x has to be bigger than 9. Okay? Alrighty. Last lesson of the unit, and if you have any questions, let me know.